Hi, today I'm going to do a think aloud around this I can statement. I can use models to support me when I add and subtract. Please watch what I do, listen to what I say, and keep a record of it so we can discuss it later. This is the problem that I want to solve. Hillary has 64 stones she collected at the beach. John has collected 131 stones. Who has collected more stones and how many more? I'm going to answer the question of who's collected more first. And I'm going to do that by thinking about a benchmark number, 100. So John's collected 131, which is more than 100, and Hillary's collected 64, which is less than 100. Therefore, Hillary's collected less than John. John has collected more than Hillary. And in order to answer the second question, I need to figure out how much more. How many more stones does Hillary need to get to John? In order to answer that question, I'm going to imagine a number line in my head. It's called an open number line because it only has two numbers to begin with, the 64 and the 131. All the other numbers are just going to clutter my thoughts for now, so I want to just keep focused on the 64 and the 131. Can you imagine what that looks like? Let me give you an example right here on the board. So in this first case, one of the ways I can think about solving this is jumping by tens. So I'm imagining in my head jumping from 64 to 74, and then 74 to 84. It's okay that these aren't exactly the same, they're just meant to represent my thinking. That's again one of the beauties of the open number line. 10 more is 94, 10 more 104, 10 more 114, 10 more 124, and 10 more 134. So that actually got me past 131. So I can count 1, 2, 3, 4, 5, 6, 7. 7 tens, so there was 70. But I'm going to need to jump back 3 to get to my final destination of 131. So 70 minus 3 is 67. So Hillary needs 67 more stones in order to get to John's 131. Now that was a lot of work. The beauty of the open number line is it allows us to think about things flexibly. So let me try maybe another approach. In this case, I'm going to try to jump to friendly numbers. So I'm going to start by jumping from 64 to 70. So I've added 6. And then from 70 to 100, I've added 30. And then from 100 to 131, so I've added 31. So 6 plus 30 plus 31 equals 67. Great! I not only checked my original answer, but I also found a way that seemed a little more simple, a little more efficient. Speaking of simple, one of the ways that I often solved problems with smaller numbers was using something like doubles. I wonder if doubles will work here. Again, the open number line can support my thinking to see about that. So when I look at 64 and I think about the double of that, I can see that jumps to 128. 64 and 64 is 128. And then 3 more, 129, 130, 131 will get me to my final desired destination. So here I've done 64 plus 3, again 67. Wow, that was really easy. Now of course doubles won't always be that easy with larger numbers, but it's nice to know that the open number line will allow us to check that out as a possibility. So, that's the end of my think aloud. What did you see and what did you hear?